So we had talked about how to connect the triangles to circles to sine graphs. So I want to review that real quickly. So here we have a triangle, and here is a circle, and here is the axis where we're going to be putting the sine graph. What we had discussed was that if we were to take the angle of this triangle coming from the center out, the angle of it, and take the sine of that angle, and of course from SOHCAHTOA we know that that sine is equal to the opposite side, which is the height of the triangle, divided by the hypotenuse, which is actually the radius of the circle, So I am actually going to use some different words when I write this. I'm going to use the word height, and I'm going to use radius. Now, of course, those are the same thing as the opposite side, because the angle to opposite is actually the height of the triangle, and the radius of the circle is also the hypotenuse of the triangle. And what we said yesterday was that then if we solve that out for the height, so therefore the height is equal to the sine of that angle times the radius. Okay? That's what we had worked out yesterday, and we had then taken that and we had plotted it. So let's take a look here. If we first said, let's find what is the height of this triangle that's on this axis line here. Well, the height of that yesterday we said was 0. So you come up here and you say that is 0 degrees. On this is 0 degrees. So that's going to put a point right there on 0 degrees and 0 height. Now the next one we did, let's take this triangle right here, and let's say that that is a 30-degree triangle. If that's a 30-degree triangle and the hypotenuse was 1, then it's going to be something less than 1, because if this is 1, well then the height is less than 1. So we said the next point was going to be maybe here. Eventually we will add in more lines, so then we could say, well, what about this one here? Well, clearly that one's closer to 1. The height of this triangle is closer to 1, but the hypotenuse is the same, so it's going to come up a little bit higher. And then when we get to the top of the triangle right up here at 90 degrees, that height is the hypotenuse, that is the radius, so that must be equal to 1. So then what we said was that one was right up here. And then as we come down the other side, we can put one here. Let's say that was 45 degrees. Okay, well, we're coming down, so now we're at 90 degrees. This is a horrible video. Okay, so I'm going to try to say this a little differently. So as the angle keeps increasing and we go around this circle further and further, making these triangles, we keep on moving on down this line. And the height, as you see, the height is 0, then the height is a little taller, then the height is a little taller, then the height is at its maximum height, which is 1. Then the height is going to be shrinking, shrinking, shrinking until it gets back down to 0. So that's actually a little better. So then the height starts coming back down this side until it gets back to 0. Then once you get to the bottom side, notice we were here, right? We're spinning around this way. So now let's go here. So now the height is going to start getting negative. It's getting negative, bigger and bigger and bigger as it comes down, and now it's all the way at the bottom. So that actually causes this thing to start, you've got these negative heights down on this side. Okay? And then what we end up with, once we get past this spot right here, that 270 degrees, well now the height was -1, and then it starts getting smaller, 0.9, negative 0.8, negative 0.7, negative 0.6, negative 0.5, negative 0.4, negative 0.3, negative 0.2, negative 0.1, all the way back down to 0, which of course gets your graph coming back up as these negative 9, 8, negative 7, negative 6, negative 5, negative 4, all the way back down to 0. So you end up with this sine curve, which is kind of what we end up drawing here, right? This nice sine curve. And we're really measuring the heights of the triangle, the heights. So there you go. That's a quick recap on yesterday. So right now what I would like you to do is you're going to need to pause it, and because I didn't really draw it to scale, so let me zoom in on it. This is the graph we're going to be looking at. And you have point A, B, C, D, E. Okay, there's 5 points there. What I want you to do is go, okay, point B is at 30 degrees, point C is at 90 degrees, point D is at 180 degrees, point E is at 320 degrees. And then this, remember, these are the heights of those triangles on that circle. So notice, we were talking about circles that have a radius of 1, and this only went up to a 1. But here we're going up to a 2, so what does that mean about the circle? Think about that, and then estimate what do you think that this height is, and what is this height, and what is this height, you know, what are these heights? And try to draw out the circle with those 5 triangles in them, with approximating these degrees here, the 0, the 30, the 90, the 180, and the 320. Okay? That is the assignment there. Whoop, there we go. That is the assignment there. And then it's to answer these questions also. If the sine graph will show the relationships of the height to radius, which is what you just did, what's the cosine graph going to show? Answer this question on a separate sheet of paper, right at the bottom. What do you think the cosine graph will show? Think about SOHCAHTOA. What is it doing? And then I would like you to sketch the appropriate cosine graph and label the points A through E. So that means that once you know what the cosine graph is measuring, you're going to need to go back to the triangles that you drew for this picture here. What were the triangles in the circle that you drew? And then think about the cosine and what is it measuring, and draw a new graph. It's not going to be this one, I guarantee it. Okay? It's going to be slightly different, but it's still measuring the same kind of things. You're going to try to think about that. Okay? Good luck.